When most people think of engineering, they most likely envision truss bridges, space shuttles, and more. What most people don't consider, though, is how statistics is involved in many of those structures, especially regression analysis. Regression analysis refers to how two or more variables relate to one another through a non-predictive manner, according to the Devore text. If there is a linear relationship between the variables, then there is a linear regression model. Basically, linear regression models are formed to help create a predictive model for the variables in question. Typically, one variable is fixed and independent while the other is unfixed and dependent, according to the Devore text as well. Data is collected and plotted as a scatterplot. If a line of best fit is formed and there's approximately a linear relationship between the variables, then a linear regression model has been successfully formed. Linear regression can be applied to various situations, and it can have its pros and cons depending on the outcome. It can have many advantages. One positive aspect of linear regression is that it is easy to implement and use according to route. It is not very difficult to set up, simple, and easy to analyze. Also, if a linear relationship is found between independent and dependent variables, this relationship can be utilized for future experiments to see if similar results occur. However, linear regression has its disadvantages as well. One negative aspect of linear regression is that outliers can significantly affect the relationship between the two variables according to route again. Also, linear regression assumes that there is a straight line relationship between the variables, but usually this is due to a line of best fit that most closely resembles a linear line, also according to route. This means that even though the relationship looks linear, it is not quite accurately represented as a linear relationship. Even though linear regression has its advantages and disadvantages, it has useful applications for different engineering purposes. It is commonly used in programming, including the software known as MATLAB. Linear regression models can be utilized to determine relationships between two variables by entering data from an experiment. From there, algorithms can be constructed based on the model. Linear regression also has applications in aerospace engineering. For example, one study used regression modeling to evaluate the cutting speed of an aerospace alloy using wire-cut electrode discharge machining, WEDM, according to Garg, Kumar, and Nain in 2017. In the article, the researchers were trying to predict a specific value for the cutting speed of WEDM for the aerospace alloy Udamet L605. They decided to use linear regression to try and predict this value in order to figure out what cutting speed is needed to process the alloy. After linear regression is applied, the model showed that there are acceptable cutting speeds for processing the alloy when compared to a non-linear regression model that was also constructed according to the researchers. Therefore, linear regression can be very useful in engineering applications depending on the situation.